I built a finance brain with Claude and Obsidian that gives me permanent memory of an entire business. So it no longer starts from zero every single time I start a new session in Claude. It already knows the company, it knows the financials, it knows the operational history and how every report I've ever fed it connects to the previous ones. Now the reason this matters is because almost every AI workflow in finance still operates on temporary context. So you upload the files again, you explain the business again, you restate the assumptions again, and then you manually reconnect historical information before any real analysis can begin. And even then, the AI can still hallucinate or miss relationships between reports because it only sees isolated pieces of the business instead of the full picture. I'm going to show you how to build the entire finance brain end to end. I'll ingest 26 real airline business documents into it. Then I'll use it to reconstruct the full year 2024 turnaround and build a forward-looking full year 2025 financial model directly in Excel. Remember, if you want the prompts and the data sets from this video, they're all in my free community and the link is in the description below. Now, let's get into it. What the finance brain actually is. Before we get into the build, I need to explain what the finance brain is because the architecture is different from anything that we've covered before. In a normal AI workflow, the business context lives inside the conversation. You start a chat, you upload reports, you explain the company, and then the model holds that information until the session ends. Now, the moment you open a new chat, all of it is gone. So that is why finance work with AI keeps feeling repetitive. The analysis itself is fast, but the setup that has to happen every session is what slows you down. The finance brain moves the business context out of the conversation and into a permanent vault that lives on your machine. Obsidian is the application that holds the vault. It's a local markdown-based knowledge system, and the important part is that notes inside it can link to each other and form a connected network rather than just sitting in isolated files. Claude reads from the vault, it writes new notes into it, and it connects every new piece of information to what is already there. So the company is effectively, it becomes a navigable knowledge system. Each new report, each meeting note, each dashboard or earnings call gets ingested once, and then it stays in that vault permanently. And then from that point forward, Claude operates on top of the vault instead of starting from a blank slate every time. Now that changes what you do with the session itself. So instead of using it to rebuild context, you use it to do actual work, turnaround analysis, forecasting, valuations, and scenario planning. The kind of analysis that normally takes a finance team weeks of cross-referencing now starts with the context already loaded. Setting up the vault. To set this up, I go to the Obsidian website, which is on screen now. I click Get Obsidian. I download the Windows installer, I run it, and then let it finish. Now, once installed, I create a folder on my system called My Business. And this is the root directory for the entire finance brain. And inside it, I create a subfolder called Raw. And this is where every source document the brain will read from gets placed. For this demo, I'm working with a realistic airline business, so I've loaded 26 files into the raw folder. And these include annual reports from multiple years, quarterly financial reports, earnings call, transcripts, board meeting summaries, and a few other bits and pieces. And the files are also in different formats. So some are PDFs, others are Word documents, others are Excel spreadsheets, and there's some PowerPoint presentations in there as well, because that is how finance information actually lives inside real companies. Next, I need to create the instruction file that tells Claude how to operate the vault. So I go to Andre Karpathy's LLM wiki gist on GitHub. I click the raw button, copy the markdown content, and I paste it into a new file. Here it's going to be claude.md. I then save that file inside the My Business directory alongside the raw folder. This file is the architecture layer for the brain. Now, without it, Claude would treat the raw folder as just a pile of documents to summarize one at a time. But with it, Claude understands that those files are the input to a long-term knowledge system. So the file tells it how to read the documents, how to structure the notes it builds from them, how to maintain relationships between those notes, and how to handle new information when it gets added later on. Now I open Obsidian, I click Create New Vault, I name it Finance Brain, and I point it to the My Business directory so that the entire setup stays inside one environment. I click Create, and the workspace opens, and on the left is the file navigation panel, and in the center is a welcome page, and on the right is the graph view. The graph is empty because the brain is not being generated yet, but that panel is where the business will become visible once ingestion runs. Ingesting the company into the brain. To run the ingestion, I open Claude Code through the desktop application and select My Business as the working directory. I give it a short instruction telling it to read the file, ingest all the raw files, and build a structured, interconnected finance brain for the airline business. I approve the permissions and then I let it run. The full ingestion takes about 30 minutes. Claude is not reading the files in the usual sense. It's converting them into a structured knowledge system. So first, it sets up the extraction workflow so it can properly handle each file type. Then it processes all 26 files in batches, pulling out the figures, the operational metrics, the strategic decisions, and the people behind them. As it works through the document, it does something that most AI workflows skip. It looks across files for relationships. So a board decision in one document connects to a financial outcome in another. An operational metric in a dashboard connects to a strategic initiative described in an annual report. Where two sources disagree on a number, it flags the disagreement instead of just picking one and moving on. Once the source files are processed, Claude starts building the actual vault. By the end of the run, it has produced 78 interconnected markdown pages from the 26 source files. It's organized into a structure that mirrors how a finance team would think about the business. When I open the vault inside Obsidian, that structure then becomes visible. The sources section holds every original document converted into a readable knowledge page, so the AI never needs to open the raw files again. The financial section is the executive finance layer with consolidated pages for the balance sheet, KPIs, quarterly performance, and the company's debt and guidance picture. The entities section holds the people and assets behind the business, executives, leadership teams, hubs, competitors, each linked to the reports and the decisions that they appear in. The concept section is the operational layer, and it covers operating margin, load factor, pricing yield, fuel hedging, and ancillary revenue. And each one becomes a reusable knowledge page rather than a phrase buried inside reports. The topic section is the most valuable part. It pulls together the major strategic narratives in the business and gives each one its own deep dive page. And each topic page is connected to the reports, decisions, and metrics that all tie into it. The graph view is where the architecture becomes obvious. Obsidian visually maps every relationship Claude built between concepts, people, reports, and metrics. Initiatives link to executives, executives link to reports, reports link to financial figures, and financial figures link to operational outcomes. And the company is now a navigable network instead of a folder of files. And that is what Claude operates on top of from this point forward. Reconstructing the full year 2024 turnaround. To run the first use case, I open Claude Cowork in a completely new session, and this part is the first real test of the architecture. In a normal workflow, a new session means losing everything I've just built. I would have to upload reports again, explain the business again, and rebuild the historical narrative before any analysis could start. But instead, I just click Work in a project, I select my business, and the full institutional context loads automatically. The prompt tells Claude to use the finance brain to reconstruct the full year 2024 airline turnaround story. That builds a margin bridge showing exactly how the business moved from losses to profitability. It explains what the cost reduction program actually delivered, identifies the operational trade-offs, and it surfaces any material contradictions across reports that a CFO or due diligence team would care about. Now, this is a heavy ask. To answer it, the model has to connect information across annual reports, quarterly filings, dashboards, strategy memos, board discussions, and earnings calls all at the same time. Now, in a normal workflow, this is days of analyst time, but here the relationships already exist inside the brain, so Claude moves straight into the analysis. The margin bridge is the first part of the output. Claude reconstructs the move from operating losses to profitability step by step. It walks through revenue expansion, the impact of fuel inflation, how hedging offset part of the fuel shock, the pressures from wage inflation, and the cost reduction program as the primary driver of the recovery. Each step is connected back to specific reports and figures from the source documents, not pulled from generic industry assumptions. The next layer is where the analysis gets sharper than a normal summary. Claude does not present the turnaround as a clean success story. It identifies what the cost program actually cost the business. The most important ones are engineering and finance talent losses that weakened operational resilience, marketing cuts that softened brand awareness, and a rise in customer complaints from service quality pressure. So these come directly from the source documents that Claude linked during ingestion. They show up as a part of the same narrative as the margin improvement, not as a separate footnote. The contradiction layer is the part that would be almost impossible to do manually at speed. As Claude moved through the reports, it found that the operating loss figure in the annual report did not match the sum of the quarterly filings. The cash balance definition changed between those two reports. The leverage ratio is calculated different ways in different places. So it does not invent a single answer to any of this. It just surfaces the disagreement, names the sources, and then leaves the resolution to me. And that is exactly the behavior that you'd want from a system supporting real finance work. Building the full year 2025 financial model. The second use case shifts from reconstructing the past to building forward. So I open another new Claude co-work session. I select my business again, and the brain loads with the same context. The prompt asks Claude to build a forward-looking full year 2025 airline financial model with quarterly projections, margin expansion assumptions, fuel risk scenarios, leverage outlook, and dividend readiness analysis. Then evaluate whether the international expansion and the long-term growth plan can realistically support analyst valuation targets and deliver it all in a clean Excel file. Before Claude starts modeling, it does something I just want to pay attention to. Now, it pauses and it asks 3 calibration questions. Which airline the full year 2025 model should cover, how conservative the base case assumption should be, and what valuation benchmark to use for comparison. So this is exactly the behavior that you want from a forward modeling system. Forecasts depend heavily on management stance and valuation philosophy, and the model is just refusing to invent those decisions on its own. So I answer the questions and then it starts building. During construction, Claude catches its own mistake. The first pass produces operating margins around 22%, which is materially above what is realistic for the airline. So instead of just continuing with the bad output, it stops and it diagnoses the problem as a yield calibration mismatch combined with a DNA double counting issue. And then it rebuilds the assumption layer. The next pass settles into a realistic margin range that lines up with management guidance. That self-correction only happens because the brain holds the historical operating structure that lets Claude recognize when a forecast has drifted outside the company's real economics. Now, the final workbook has 9 connected tabs, and I'll not walk through every cell, but the architecture is worth explaining because it's what makes the model reusable rather than a one-shot forecast. The assumptions tab is the engine. Every operational driver the model uses lives here as an editable input. Capacity, load factors, yields, fuel pricing, capital expenditure, dividend assumptions. The rest of the workbook flows from this tab through formulas, so changing any input here recalculates the entire model automatically. The quarterly P&L is the core forecast layer. It moves through revenue, costs, and profitability quarter by quarter, with everything driven by the assumptions tab rather than hard-coded. The margin bridge sits next to it and it reconstructs how operating margins are expected to expand from the historical base into the projected state, and it attributes the move to specific drivers like premium mix, capacity discipline, and fuel tailwinds. So the forecast comes with an explanation rather than just a single number. The fuel scenario tab is a sensitivity engine. So it runs the model through bull, base, and bear fuel environments, and it quantifies the EPS impact of each move. Now that matters because fuel volatility is one of the biggest single risks an airline carries, and seeing the sensitivity in one tab tells you how much earnings depend on fuel staying within a certain range. The leverage tab models how debt comes down over time, and it tracks the path to investment grade. The dividend tab connects the operational forecast to capital allocation, showing free cash flow generation, dividend coverage, and what is left over for buybacks. The international expansion tab models Atlantic, Pacific, and Latin growth separately because the airline's long-term story depends on those regions individually rather than as a single global number. The valuation tab is where everything ties together. Claude triangulates implied valuation ranges using 3 different methods and compares them against sell-side consensus price targets. Instead of producing one number, it shows the range of what the operating assumptions imply for equity value. Now, because the entire workbook is formula linked, the model is reusable. If you change the fuel price assumption or adjust capacity growth or modify the dividend policy in the assumptions tab, then the whole thing resolves all the way through to the valuation triangulation. And that is the artifact that comes out of the second use case. A reusable institutional model, not a one-shot forecast. And that is the full system, a finance brain in Obsidian that holds the entire company in a permanent vault. A turnaround reconstruction that runs end to end on the brain instead of starting from raw files. And a forward-looking financial model that builds itself on top of the same context. The setup work that normally happens at the start of every single AI session is now done just once, and then it's reused permanently. Now, if you want the prompts or the Claude.md file and all the data sets from this video, they're all in my free community, which is linked in the description below. I'll see you next time.